Hello everyone, this is Siamak Farshidi, a PhD candidate from Utrecht University. I'm here today to present one of our recent publications in the Journal of Systems and Software entitled Capturing Software Architecture Knowledge for Pattern-Driven Design. Let me first give a brief description of software architecture patterns. Software architecture patterns are universal and reusable solutions to commonly occurring problems in software architecture. Each architecture pattern describes high-level structure and behavior of software systems and addresses a particular recurring problem within a given context in software architecture design. Architectural patterns are aimed to satisfy several functional and quality attribute requirements. In literature, sometimes the term architectural patterns and architectural styles used are interchangeably, since they are in sense the same concepts and only differ in their description forms, as Paris Afcario and Sutton actually mentioned in their publications. Pattern selection can be considered as a decision-making process. Actually, a software architect runs into a design problem. She looks for actual features she thinks that can solve this problem. She goes through description of several patterns and identifies several candidates. And finally, she identifies an optimum pattern or set of patterns for her problem and go through tactics to make sure it works properly in the context. Actually, the pattern selection process is challenging for software architects as knowledge about patterns is scattered among a wide list of a wide actually range of architecture. So this knowledge should be collected, organized, stored, and quickly retrieved when it is needed. Actually, we employed manual search and automatic search by following this search process, as you can see here, in order to extract 232 primary studies. And these high-quality primary studies promoted to the knowledge base of the SLR for performing the knowledge extraction process. Afterward, we followed Mayer's and Newman guidelines to conduct a series of qualitative semi-structured interviews with 12 senior software architects to explore expert knowledge regarding architectural patterns and evaluate the outcomes of the SLR. Actually, this figure provides an overview of the number of studies that were considered each pattern as one of their design decisions. The primary studies that discuss the patterns are spread across the early years of the emergence of software architecture, 1990 to 2019, actually the recent 29 years. To prevent potential biases, we only consider the pattern of three primary studies, and each selected publications was at least relevant to a particular pattern and discuss its characteristics such as liabilities, strength, component connections, and typologies. Consequently, 29 patterns satisfied the constraint and were included in this study. As you can see here, actually we have top 5 patterns such as client server, layers, pop-on filter, SAW, and MVC. And actually, again, as you can see here, the number of primary studies from 2005 has increased significantly, and more than 20% of the primary studies were published in 2010 and 2011. Also investigates the possibility of existing trends among researchers in selecting patterns. As you can see here, we observed that SOA, cloud-based cloud computing architecture or space-based, and microservices gained more attention in recent years. And also patterns such as C2, PAC, RPC and RPC actually, besides batch sequence patterns, are not discussed widely in academic literature. One of the fundamental concepts in software architecture specification is identifying a required level of measurement of quality attributes or system qualities such as performance, security, availability, and reusability. In literature, patterns are described according to their functionality that they deliver and their strength and liabilities that shows concerning several quality attributes. We try to identify most widespread quality concerns that were considered in literature. Actually, this figure indicates the quality attributes that were explicitly mentioned in at least 3 primary studies. We encountered 40 relevant quality attributes according to the results of the analysis. Reusability, flexibility, performance efficiency, scalability, and maintainability are top 5 software quality attributes that were investigated and reported in more than 30 primary studies. And also, it is interesting to highlight that characteristic of ISO IEC 25010 standard were considered as quality concerns in primary studies. However, sub-characteristic of this standard, such as operability and accountability, were less discussed in the primary studies. Actually, patterns and quality attributes are not independent and have significant explicit or implicit interactions. Interactions can be represented as reusable knowledge. For instance, layers as a pattern involve a trade-off between efficiency and maintainability. In the knowledge extraction phase of the studies, we realized some inconsistency regarding the observed impacts of patterns on quality attributes. For instance, some authors actually mentioned that efficiency is a strength of pipe and filter. However, some others mentioned that this is a liability for this pattern. Therefore, efficiency can be considered as both strength and liability of this pattern. And in order to actually quantify the impact of particular pattern on quality attributes, we employed fuzzy logic as a method to aggregate the extracted knowledge regarding this impact. And each cell of this matrix, as you can see here, contains 2 rows. The first row is a triple, including the number of studies that reported a particular quality attribute as a liability, neutral, and a strength for its actually corresponding pattern. And the decimal number in the second row of these actually cells shows the result of the fuzzy calculation for the pattern. And liabilities actually are red cells, strength are green cells, and neutrals are yellow cells, and white cells actually show unknown, that we didn't actually see any evidence to find this mapping between a quality attribute and pattern. Actually, this figure shows the application domain of the identify patterns. We categorize the observed application domains based on the suggested software taxonomy by Forward and Lethbridge. And also the numbers in the cells shows the number of studies that discuss the corresponding application domain of an architecture pattern. And actually the cells in dark blue indicate the categories of the application domain. Okay, in the discussion we need to actually mention that software architect need to have a more explicit awareness of software architecture trends and evaluate them in the context of the system requirement. And if we actually look at traditional building architecture again, it does not come as a surprise that actually architects are sensitive to trends. It is presently impossible to assess which patterns are compatible and frequently using combinations, even though practically all systems implement more than one patterns. And besides reporting, academics have to responsible to define what architect need to make explicit. And the majority of the primary studies focus only a limited set of patterns and quality attributes, and they were more concerned with generic quality attributes such as those in the ISO IEC 25010. And software architecture tactics are a subclass of design decisions and focus on improvement of particular quality attributes. For instance, ping echo and heartbeat are two tactics that can be selected to improve reliability. If selecting and applying sets of patterns without considering impede some of the quality attributes, these tactics actually can be employed to improve a system's quality attribute.